The sequence that we have is an, which is equal to 3 to power n times 7 to power negative n. To find the limit of this sequence, you're finding the limit of 3 to the x times 7 to power negative x when x goes to infinity. So whenever we're talking about the sequence, the limit is at infinity. We are interested in the end behavior of sequence. Okay, this guy can be written as the limit of 3 to power x times 1 over 7 to power x as x goes to infinity. In terms from algebra, these two can be combined as 3 over 7 to power x as x goes to infinity. So, what is the limit? 3 over 7 is less than 1 and it is more than 0. So, when you're raising it to a large exponent, the limit is equal to 0. So we found the limit of this function to be 0. What's the meaning of that? It means that the limit of your an, your sequence an, as n goes to infinity is equal to 0, since we have a unique numerical value. The limit exists and the sequence is convergent to 0. Next example for you. The next sequence is an, which is equal to 3 times square root of n over square root of n plus 2. To find the limit of this sequence, equivalently, we find the limit of the function 3 square root of x divided by square root of x plus 2 as x goes to infinity. Again, intuitively, you can take a look at the behavior of these two and say that since the degree of the numerator, degree of 3 times square root of n, is equal to the degree of square root of n plus 2, so we can ignore the terms with lower power or lower degree. What do I mean by that? It means that the limit of 3 square root of n divided by square root of n plus 2 as n goes to infinity is the same as the limit of 3 times square root of n divided by square root of n. You can basically ignore the terms with lower power. And then in calculating the limit as n goes to infinity, you can cancel out square root of n and square root of n. You expect the limit to be equal to 3. Now let us verify that using the algebra and calculus that we learned in elementary calculus. This limit is equal to the limit of 3 times square root of x divided by square root of x over square root of x over square root of x plus 2 divided by square root of x as x goes to infinity. This guy in turns can be written as the limit of 3 divided by 1 plus 2 over square root of x as x goes to infinity, but 2 divided by infinity is 0, so this guy is equal to the limit of 3, but the limit of constant function is equal to the fixed value that you have, no matter where your x is going. So since you have a unique numerical value, you can say that the sequence is a convergent sequence. So since the limit of an as n goes to infinity is equal to 3, which is a unique numerical value, so the limit exists and the sequence is a convergent sequence. Let's cover another example for you. Here you have the sequence an, which is equal to e to power -1 over square root of n. To find the limit of this sequence, we can find the limit of e to power -1 over square root of x as x goes to infinity. This can be written as the limit of 1 divided by e to power 1 over square root of x as x goes to infinity. So first, get rid of negative exponent, write it on the denominator with positive exponent, then take the limit. When we take the limit, this is equal to the limit of 1 divided by e to power 1 over infinity, which becomes 0. Okay, I have 1 over e to power 0, which is 1. So the limit is equal to 1. Since the limit of this function is equal to 1, it means that the limit of an as n goes to infinity is equal to 1. And since the limit is a unique numerical value, so it is convergent. Next sequence, you have an to be equal to 4 to power n divided by 1 plus 9 to power n. To calculate the limit of this sequence, equivalently, we find the limit of 4 to the x divided by 1 plus 9 to the x, as you saw in elementary calculus, but the limit is when x goes to infinity. Intuitively, you can say that, hey, 4 to the x or 4 to n goes to or grows much slower than grows slower than 9 to the n. What's the meaning of that? At infinity, the quantity on the denominator is going to infinity much faster than 4 to the n. So intuitively, you have a number divided by infinity. So intuitively, you have 0 as the limit. But let us do the algebra to check the work. This guy can be written as the limit of 4 to the x over 4 to the x divided by 1 over 4 to the x plus 9 to the x divided by 4 to the x. If you do this, well, you can't get rid of the quantity on the denominator that easily. but you can get rid of the quantity on the numerator. So let us divide by 9 to the x to see this without going over another step. So here you have 9 to the x, 9 to the x, 9 to the x as x goes to infinity. So this guy can be written as the limit of 4 over 9 to the x divided by 1 over 9 to the x plus 1 as x goes to infinity. But on the denominator, 1 over 9 is less than 1. When it goes to infinity, this guy becomes 0. The same for 4 over 9. 4 over 9, well, this number is less than 1. When it goes to infinity, this guy becomes 0. So what you have? You have 0 divided by 1, which is indeed equal to 0. So the limit of 4 to the x divided by 1 plus 9 to the x is 0. So for sure you can say that, hey, the limit of an as n goes to infinity must be equal to 0. So since the limit is a unique numerical value, so the limit exists and the sequence converges to 0.